function, then what you need to do is take notes as the person's going over it. You also need to critically think about and ask the question, do I understand why this is correct? Because you have to be able to do these things, identify each of these types of functions. All right.
God told me to go right though.
So,
I ain't my hand right there.
it's okay.
Fantastic, man. Let's go.
So, group 3, y'all had D. Who from group 3 is going to present?
Brooklyn.
They both voted you, Brooklyn. Y'all should have decided this earlier. Come on. Let's go. We all got faith in you.
Need one of them.
Better make sure you know who's coming up.
Wrong.
Once I call you.
Then you gotta go.
Y'all gotta agree.
I already wrote. Wrong. Say something. What's coming out your mind?
Who wrote it up there?
Y'all silly.
They told me to wrong. They said right. So
Y'all scrubs. All right, Brooklyn. Start us off.
Okay, so we did D.
Yep.
So we got linear additive because it plus 5. Each time. And for our explicit, we did y equals 5 and then x plus 2. We were going to do -2, but you don't have to do that because you already added a negative, which is 17. And then for our recursive, we did f of n equals f n minus 1 plus 5, which is already a change. And we did the first point, -2 and -17 down here.
Okay. Anyone have any questions? By the way, I see one person writing down D, but I don't see many others when only one group worked on D. Are there any questions that any of us have for Brooklyn before she takes a seat?
I didn't know you was smart.
Good job. Come on.
Oh, wait, no, okay, that's a
That's rude.
That is actually a good copy.
All right, one thing I do want to clarify, right? Remember, it is a linear what? Function. We need to keep in mind that it's a linear function, and that is because of an additive rate of change, right? So you got to separate the rate of change from the type of function. A linear function, because it's an additive rate of change. And this is an important distinction that we need to make sure. They did this well, but can anyone explain to me why it's an x plus 2 right here? What type of function did she have? Well, is the function additive? It was a linear function, so she's using which equation of a line? Point slope, right? Y equals m times x minus x1 plus y1. So why in the world did this become a plus 2? It says x minus x1. Zay, you're staring at me hard, but like you haven't told me why, or even thought about why is this an x plus 2?
Wait, no, for me. Huh? I'm lost.
It's because you ain't paying attention, my man.
I'm paying.
My point is you're staring at me hard, but you have not even thought about the question I just asked. What you got, Tony?
Well, you told us that because it was x minus x, we had x minus -2.
So notice they indicate this in the recursive. You use that point -2, -17, right? And so when you substituted in for here, you said it was minus a -2?
Yeah.
Do we have to do x minus a -2? X minus -2?
Nope.
What's an easier way to write that?
X plus 2.
Plus 2. Right, we're going to be adding here with the x when the x was actually a negative. Similarly, why is this minus 17 when it says plus y1? Because we're adding a negative 17, right? And so instead of adding a negative, we just subtracted. Any questions at this point? We good with that? All right. Who's coming up from group 2?
There's a girl.
Y'all group
Dewan, you group one, bruh.
Yeah, sure.
Come on, let's go, somebody. Thank you, RJ.
You going out there? Good job. No
We
game
live
point.
in a democratic society.
I told you I would have did it.
Amy's like, nah, Dewan, I don't want to touch you. Thank you. You can't tell right now, but RJ is doing a great note of making sure it's not just exponential, it's an exponential function. Good.
It was a scholar. I told you you can do it, man.
I know he can do it.
All
Alright.
My boy Trey Dowd here.
So we did.
Really quickly, just so that we're getting a little bit better at this. Have y'all noticed that I usually don't stand facing the board?
Yeah.
I stand to the side, and I point at things and I turn towards it, but you need to be able to face your audience, face the people you're talking to when you're explaining things, okay? I know it's uncomfortable, but this is how we get better at it.
Get on this side.
It's all about that growth mindset. There you
Yeah,
go.
from the beginning of the year.
That's right.
We can barely see the question. Yeah, that's right.
Alright, go ahead, take it away.
You jack
We did exponential function and multiplicative rate change because it's times in by 5. Exponential.
Hey RJ, can you back up just a little bit? I don't think Destiny can fully see everything. There you go.
Explicit equation was y equals 1 times 5x because we use point slope. And then our recursive equation is f of n equals f of n minus 1 times 5. And then it was f of 1 equals 5. Because equals 5 is our rate change.
Okay, does anyone have any questions based on what RJ said?
Nope.
Okay, RJ, I want to ask you a couple quick questions. You said f of 1 is equal to 5 because that's your rate of change, right?
Yeah.
I thought that...
We use this one.
That's the
so f of 1 equals 5, that's your starting point?
Yeah.
There we go, right? So we want to make sure we're indicating that. Remember, the f of n equaling f of n minus 1 times 5 is that rate of change. Really quickly, that's not the point you use, though, for your explicit equation, is it? Uh-oh. Got deer in the headlights, we're not sure? Does anyone remember in group 2 which point you used?
Yeah.
Which point did you use?
We need 0 1, right?
Yeah.
We use 0. Everyone's 0 1.
So, and it's okay, I just want to point out, like, recursive, you use that point 1 comma 5, but in the explicit, you use 0 comma 1. Why would it be a good idea to use 0 comma 1 to write the explicit equation?
And that's the starting point.
I mean, they can all be starting points.
It's a intercept.
Which intercept?
Wow. Yeah.
Tony, how do we know that 0 comma 1 is a y-intercept?
I don't know.
No idea?
Yeah.
Oh, Dewan, do you know? Oh, you haven't even taken a chance to think about
Look
it.
at it, dude.
Well, how do we know that 0 comma 1 is the y-intercept?
This is 0.
What about the 0?
The x is 0.
Oh, so you did know. Stop giving up on yourself, right? So the x is 0 there, so that's a y-intercept. Right, that's a good place to start. Thank you, RJ.
I knew it.
All right.
Why you ain't say it?
So here, hey, stop John and listen. One thing I want to quickly talk about before I get group 1 up here for F, I do want to point this out. You started at this 1, right? And that's something to keep in mind, right? We're starting at 1, and then what are we doing to the 1?
Multiplying by 5.
And then how do we mathematically show repeated multiplication?
Exponent.
With an exponent, right? So raised to the x. But because that was the y-intercept, it would be x minus 0. Do I have to show that minus 0?
No.
So that is a very good equation to write. But you could have done any point up here as a starting point, right?
Yeah.
That's probably the most efficient. Similar thing here. Y'all did a point slope, right? But could you have done slope intercept?
Yeah.
Yeah, would that have been a little bit easier?
Yeah, because it's 0 negative 7.
So my slope is still 5. X, my y-intercept is negative 7. These are things that we want to look for. That y-intercept is going to make our life easier. We don't have to use point slope if we have the y-intercept. All right, group 1. Who's coming up? Amity, I think? Yes, sir.
Would it be more favorable if we did the,
Okay, come on up.
if we did the intercept?
I mean, they're both correct. I'm just going to use slope intercept because it's easier.
How would it make it easier?
Well, tell me which equation is easier to write. This or this?
Yeah,
The first one, right? It's just that there's less involved.
all right,
You know what I mean?
yeah,
You can only use it when you have your y-intercept, but if you have the y-intercept, I'm going to go with the easier option.
it's more efficient.
Yep, and that's exactly it. We want to learn how math works so that we can be more efficient.
It's not important.
All right, Andy, take it away.
So it's quadratic because it subtracts and it adds. And we chose the explicit, this equation, I forgot the name for it, because if you take any of the numbers in the x column and you give it an exponent of 2 and add 5, you'll get any of the ones in the f of x column. And I don't remember anything with the recursive equation, I'll be honest.
Okay, let's go over it a little bit and take some more notes on it then, okay? But that's a good start. Before Andy takes a seat, does anyone have any questions at this point?
What's your rate of change?
That plus 2x minus 1, is that what you're talking about?
Mm.
You talking about on the recursive equation?
Or the type of characteristic.
Oh, you're talking about under characteristics?
Okay.
Oh yeah, what type of rate of change is it?
It's linear.
Linear.
It's linear.
I forgot to write that up there.
Killing us, Dewan. Alright, you're good. Really quick, a couple of notes. So thank you for knocking that out for us, Amity. Couple of quick notes to add in on that, right? It is a quadratic function, and Amity did bring this up. She said it was both adding and subtracting, I think is what you said, right? The mathematical way to say that is it is both,
Increasing,
Decreasing.
first it is decreasing. Notice we see that through the subtraction, and then after it decreases, it increases, right? Now, that is a characteristic of a quadratic. That does not define the quadratic, though. I loved what RJ said at the end, or asked about, is what's the rate of change, right? It is linear, right? So it is a linear rate of change. And you can see that here. These first set of differences, are they constant? What? Do you have a question, Tony?
Yeah.
What's up?
What would define a quadratic function?
Say that one more time.
What would define a quadratic function?
You have to have a linear rate of change.
Increases and decreases.
There are other functions that have increasing and decreasing. If it is a linear rate of change, it is quadratic.
All right.
Yes, sir.
Do we have to have a strong point?
We're going to talk about that in just a second.
It's 0 and 5.
So, look right here. You see how it's -3, -1, 1, 3. Remember, that is my first, what? Differences, right? That's what defines the rate of change.
And then we got second.
And we do have a second set of differences.
It's
You see how my second differences are constant?
-2 and
It's not -2.
Yeah, formula.
It's plus 2.
Yeah.
-3 plus 2 is -1. -1 plus 2 is 1. Y'all, I need you paying attention so we can finish going over this. The first set of differences is my rate of change. But because these are constant, what type of rate of change is this? This is constant additive, so this is linear. So it's a linear rate of change. Again, Tony, that's what defines this quadratic function. Okay? So Amity did explain some of these things really well, but I want to go back over this explicit equation here. If it is quadratic, we have to know that every quadratic starts with x squared. It has to have a second power if it's quadratic, right? But if I do 0 squared, what do I get?
0.
Is that 5?
No.
No. I'm supposed to have 5 though. If I do 1 squared, I get 1, but I'm supposed to have 6. If I do -2 squared, right? -2 times -2 is?
You get 5.
4. Huh?
4.
So we
4, but I'm supposed to get 9. What can I do to each of
This should
these
resume teacher
to get 5, 6, and 9?
14.
plus 5.
Pick up an order form from the office or your original
Oh, I
teacher.
thought you said it was
Size
right.
is small through extra large or $15.
Does that make sense though, why we had to add 5 to our x squared there?
Turn in your
To
money
make it work? Okay.
to the office or your enrichment during 4th to
So
5th
last detail on this.
The deadline has been pushed back to April 6th.
So,
The March free book giveaway is going on in the library. Stop by and pick up your free copy of The Darkest Mind by Alexandra Bracken.
I want to point out that this is the equation they have written down for the rate of change.
Girls, they will
Now,
be held
you asked a great question earlier. Do we need a starting point? Yes or no?
Junior applications need to submit a resume and a
Yes.
web-based essay submission.
And Dawn, I liked the comment that it could be 0 or 5, but you need to include that. Secondly, if we're using in here,
at 7:40.
what variable do I need to use here?
Fellowship and a word of encouragement.
In. I either need to use in or I need to use x.
Prompt tickets, pickups
So,
are for in-person students.
remember,
Through
we can
March
make
29th
a table,
in Mr. Langston's room in room 215.
and that's what they did to look at the rate of change. Right, so this was my rate of change here. Notice I am repeatedly adding 2. And what was the y-intercept? -1. That's where they got 2n minus 1. That is the rate of change. Or that is the, yeah, that's the slope-intercept form. Now I do want you to notice, actually, yeah, we'll leave it there. We'll talk about how to verify that tomorrow. I want to show you a couple quick things on your homework. So, first things first, you have an accuracy homework check tomorrow, which means it's going to be worth a little bit more points. Don't say yes yet because you don't justify enough. If we're going to identify the rate of change, we need to indicate m equals what? How do we calculate slope?
Rise divided by run.
Rise divided by run.
That don't work.
Oh!
Oh, I'm sorry.
So notice I need to pick 2 points. Okay, I'm rising 4 and I'm running 1.
Hold on.
And the graph is where it's easiest. But I need you to notice even over here, when you have a table, how do we calculate slope still? Oh, how do we calculate slope? How do we calculate slope?
Rise divided by run.
So you need to look at the rise and at the run. Even when you have 2 points, make a graph or make a table to find your rise and your run.
So just find the make a table. So I took pictures of them for no reason.
There's your homework. 18 and 19 for accuracy.
Okay, 18.
6.2 ready number 1 and set number 9. But you need to clearly identify your rise and your run, and you need a table or a graph to justify it.
You're a troll. You're a real damn troll, dude.